делами 5,5 миллионов тонн от разводов пустынины, из них почти 3 миллиона находятся во всех странах. Китай, Индонезия, части Япония, Корея и так далее.
There's 3 general steps in terraforming Mars. First, we need to heat the planet. That will thicken the atmosphere and allow liquid water. Then we have to protect this atmosphere with a magnetic field, and finally seed the planet and create ecosystems. For step 1, we have 3 contenders: high-powered mirrors, lasers, or redirecting asteroids. Unfortunately, nuking Mars did not qualify for a number of reasons. Out of these 3 top contenders, high-powered orbital mirrors and lasers are very similar. Both of these would be positioned in space around the planet in direct concentrated heat to the poles to melt ice caps, which in return releases CO2 and raises the temperature. However, neither of these methods would be enough, since there isn't a sufficient amount of readily accessible CO2 on Mars to raise the temperature to a point where it would allow liquid water and create an atmospheric pressure comparable to the Earth. For this reason, we would likely use a combination of asteroids, lasers, and mirrors. The idea of using asteroids does seem a bit far-fetched, but assuming we could redirect an asteroid to Mars, which is something NASA's already working on to protect Earth, it could have a substantial impact. We know this because in some sense it's already been tested. The asteroid that killed the dinosaurs released a massive amount of volatile materials. Combined with the materials from Earth, which were also vaporized in the mix, caused billions of tons of CO2 to be released. If theoretically we could get an asteroid similar or preferably a bit smaller, we could release a massive amount of greenhouse gases. Then by melting the ice caps with mirrors and lasers, we could release liquid water and even more greenhouse gases to create an atmosphere. But we also don't want to forget the magnetic field. For a quick summary, you need a magnetic field to protect an atmosphere. With none, solar winds will just dissolve it. Since Mars is small, it cooled faster than Earth and lost its magnetic field, which is why it doesn't have an atmosphere today. Studies have shown, though, that just by bringing back a magnetic field naturally, Mars may be able to recover an atmosphere 50% of that of Earth. Now, to bring back a magnetic field, it would require some significant technological advancements, so we're going to look at 2 more abstract methods. Option 1 is to use a magnetic constellation of satellites. This would entail launching thousands of satellites into orbit around Mars that act as an electromagnetic or superconducting solenoid. The biggest pros to this choice is its modularity, since we don't need to launch them all at once, and redundancy, since if one fails, we realistically would be fine until it needs to be replaced. However, there are some cons. First off, every single one of them would need a power source, thermal management so it doesn't melt itself, radiation shielding, and be coordinated. The second con is its infrastructure. Since this isn't a one-and-done project, there would need to be a factory on Mars making these satellites. The second option was actually modeled by NASA, so we're fairly confident in its capabilities. It's got a really fancy name: Lagrange Point Magnetosphere. In simple terms, it's a massive shield that goes in front of Mars and blocks solar winds. We don't need any infrastructure on Mars to build this, and although we would need to scale things to sizes never envisioned before, it's technologically feasible. Unfortunately though, this method also has some pretty significant drawbacks. For starters, it needs a lot of power, multiple gigawatts, which would need to be generated either from solar or nuclear. 9 times out of 10, when you need this type of power, you get a cooling problem. Superconductors require cryogenic cooling, which is difficult to maintain in space. This of course is all achievable with enough investments, though there are some bigger problems, such as the size, which would need to be hundreds of kilometers, and the weak redundancy if it goes offline. Mars would immediately be exposed to solar winds. Despite this, NASA did say in their Vision 2050 workshop that it could be built in the mid to late 21st century. So assuming we can redirect an asteroid or 2, send some massive mirrors or lasers to Mars, then build a Lagrange point magnetosphere, we could have a planet with liquid water and conditions supportable for early life. Which means it's time for step 3, building life. Phase 1 would involve microbial seeding, in order to make the regolith more sustainable for life. Extramophile microbes, which are bacteria and archaea that can survive in extreme conditions, exist here on Earth, but we would likely genetically engineer them to be more effective and culture them in large quantities. We would drop them in warm waters and give them between 5 and 10 years to fix to nitrogen and carbon, produce enough oxygen through photosynthesis, and begin soil formation by breaking down regolith. Next, we'd introduce fungi, lichen, and algae to accelerate organic buildup. In Phase 3, we would add hardy plants like mosses and salt-tolerant grasses. Phase 4, we'd see the first animals like ants, beetles, bees, and worms, and finally, in Phase 5, we'd expand it to small mammals and beyond. Seems like an easy process, right? Well, no, but it would be pretty incredible, and we would also be able to terraform other planets like Venus in the future. As always, I look forward to seeing your ideas either in the comments or the Discord, and I'll see you again next week.